when I'm working with trig functions, one of the things we can do is apply these trig functions to specific applications. One of those is finding heights using triangles. And in this example, we're going to go through here and we're going to say the height of the triangle. And so if we're given 65, we're given 340, and we're looking to find the height, which of the trig functions would this work with? Well, I've got opposites and adjacents. So we're going to say the tangent of 65 is equal to that's the opposite divided by the adjacent, 340. And so I'm going to go ahead and we're going to multiply through 340 there, and that's going to cancel out. So we end up with 340 times the tangent of 65. This is going to tell us that 729.13 feet is the height of the building, or could be a tree, could be anything they're looking for, right? It's just about finding that triangle and setting up the angles to work in a certain way. The last part here is using a trig ratio to solve for an angle measure. We're going to kind of take this slow at a time. These calculations can get much more complicated, but we're going to take this on trying it as if I'm using no calculator. So really what we're focused on, let me remind you, are the specific triangles. This is your 30, 60, and 90 triangles. This would be that 1, square root of 3, and 2. We also have the 45, 45, 90 triangle, 45, 45, 90. This would be 1, 1, and square root of 2. I want these up here because that's going to be important. Really what you're looking at here is the question says, when do I have an angle measure that's equal to the sine of 1/2? I know that this is opposite over the hypotenuse. So I'm going to go ahead and write that down. Right, I'm going to draw a triangle. That tends to be most of our solution processes. Here's my theta, opposite 1 and 2. What angle is this? You can look up at your triangle, and I want the angle that is opposite the 1 where I have a hypotenuse of 2. Well, obviously, if I'm telling you that it comes from one of these two triangles, and whenever you have this to solve without a calculator, it's going to be from one of these two, right? You're not going to have to kind of do this with random stuff. We would need a calculator to do that. This angle is opposite the 1 with a 2 hypotenuse. Well, that means you're going to be in this triangle. What's opposite from 1? 30 degrees, right? So theta here would be equal to 30 degrees. If I use the cotangent, number 2, here we have cotangent is the adjacent over the opposite. So I'm going to kind of sketch this particular triangle out. I can already tell you because it's got a square root of 3 involved right here. I already know that it's going to be inside of this, right? And so we're going to label it. I'm going to put theta here. It's going to be the adjacent is a 1. This is going to be the square root of 3, and this is going to be obviously 2. It's a 30, 60, 90. What is opposite the square root of 3? If I go up to my triangle that I've already written, the square root of 3 is here. The opposite of that is 60 degrees. So theta would have to be 60 degrees. And this is actually a little bit more complicated as we're solving it, and we'll get into those later. But for now, we're just getting used to kind of working backwards. The next one is not quite so easy. This this fraction has been rationalized. And if I want it to match up with my triangle, I need to unrationalize it. The good thing about that is if you rationalize a triangle twice, it undoes the rationalization. So I know that I have a radical on the top, and I want to get that to be what it used to be. Now, ultimately, you need to memorize what these two things are about to show you. I don't actually do this math every time. I'm going to multiply through. We know that that's going to be equal to 2, and the bottom is going to be equal to 2 square roots of 2. But this time, this simplifies. 2 goes into 2 once on both sides. So we really end up with 1 over the square root of 2. And cosine is the adjacent over the hypotenuse. If I didn't rationalize it, I can still do it, but it's not going to match up with the numbers that I have set up here. I would have to do a little bit of extra stuff. But just remember that when you're working and you see the square root of 2 over 2, that's exactly the same thing as 1 over the square root of 2. Just the same way, the square root of 3 over 3 is the same thing as 1 over the square root of 3. I would write these two things down and I would commit them to memory. They're really important. It's just going to be a little bit of a time saver for you. So we're going to write this down. The adjacent, so I'm going to pick an angle first. The adjacent is going to be 1, and then square root of 2, instantly I'm kind of already there. If I'm in a 45, 45, 90 triangle, then obviously it's going to be really easy to do. You know that the square root of 2 is the hypotenuse in that one. So either angle I have is going to be 45 degrees. It won't really matter. Keep going. We know that the whole number values are 2 over 1. This is the hypotenuse over the adjacent. I'm going to go back in here. Because I have a 2, I know I'm going to be in the 30, 60, 90 triangle. I'm not quite sure which one I have. I can go down here and I can write out my theta. My adjacent is a 1 and my hypotenuse is a 2, and opposite would be square root of 3. I know this well enough because I know which pieces go together. Knowing this, having these memorized, allows me to simply know which side is missing, and I don't have to kind of figure out where I'm looking. Now you will, and that's okay. Kind of look up here, and this is really getting you used to looking at the two different triangles and getting you used to seeing which ones are connected and how can I get to those solutions a little bit faster. If I look at the triangle, what's across in the 60, it's going to be the square root of 3, or it's going to be the 60 is across from the square root of 3. And so we have theta is equal to 60 degrees. Cotangent equals 1. Remember, get a whole number. It's going to be this over 1. So this is our adjacent and our opposite. Well, which triangle has the two sides that are the same? You're in the 45, 45, 90. So I can work this out. I don't really need to. This is a 1. That's a 1. This would be the square root of 2, but I already knew that my answer was going to be 45 degrees. Okay. When I come over to my secant, my cosecant, I'm going to do that again. 2 over 1. Remember, this is the hypotenuse over the opposite. This is the reciprocal of sine. Here again, knowing those and being familiar with them is one of the most crucial aspects of making this easy. Going back to those trig functions, making sure you know SOHCAHTOA or however you memorize it, and the 30, 60, 90, 45, 49 triangles probably is some of the most important things you can spend your time on. I'm going to draw my triangle. I'm here at my angle. I know that my 2 over 1, this is the opposite 1, and this is going to be a 2. This will be square root of 3, right? Otherwise, if it was a 2, if I were in the 45, 45, it would have been a square root of 2. What's across from the 1? I'm looking here. Here's my angle of interest. What's opposite from the 1? I can go up to this triangle. Opposite 1 is 30 degrees. And so we know that theta here is going to be 30 degrees. Now here again, I want to caution you that we may do something like this in the future, and things may be a little bit more complicated, but we're taking this one at a time. I just wanted to make sure that you guys are grasping this and getting a good overview of what we're doing. Take your time. Spend your time learning these things, and I hope this made a little bit more sense. If you've got questions, bring them to class, and we'll take care of them there.